Alright, so I do not have your test corrected yet. Intentionally, because if I would have had them corrected, then I would have put them on the quarter grade, and then some people would probably not have. So a quarter grade is what they went in with. So intentionally, I'll have them done today, and they'll be on there after 3 o'clock today, which is also when you guys should be able to have access back on the portal to see what you did. Okay? What else was I going to say about that? So far I've gotten 2 of them done, and they haven't been too bad, so, but we'll see. And 2 is not a big enough sample size, so yeah. We are going to start chapter 6 today. We're only going to do 2 sections out of chapter 6. My plan is to take a quiz on chapter 6. Really, I shouldn't say quiz. We'll call it a quest on chapter 6. A little bit longer than a quiz, a little bit shorter than a test. Call it a quest. Okay? We'll take the quest on chapter 6 on the Tuesday before Thanksgiving. Okay? So that's when we're going to take that one. That Tuesday. I think that's the 21st. If memory serves me correct. Yeah. Tuesday the 21st is when we'll take that. Okay? So that leaves today and tomorrow. No formative this week. Monday, Tuesday, Wednesday, Thursday of next week. Review day on the 20th. Quest on the 21st. So, how does that go away now? There it goes. Okay. All right. So, section 6.3 is where we'll start. We're going to do 6.3 and 6.4. There are 5 things that I want to accomplish in section 6.3. We got to talk about operations. We got to talk about domains. We got to talk about domains on operations. We got to do composition of functions, and we got to do domains of the compositions of functions. Okay? Just so you know. That's the 5 things we want to accomplish today. I want to say we're going to knock 2, maybe 3 of them out today. We'll see how far we get. Okay? So, first thing is operations. Okay? In math, what are some operations? Adding is an operation. Subtracting is an operation. Multiplying is an operation. Division is an operation. Not an operation. That is all. Very, very good. There are only 4 operations in math. You can only add, subtract, and multiply and divide. That's all you can do. Okay? So today, we're going to add. We're going to subtract, we're going to multiply, and we're going to divide. Okay. Okay? All right? So, if one of our functions is 7, and the other function is 3, okay? If I add them, what's my new function? 10. If I subtract them, what's my function? 4. If I multiply them, what's my new function? 21. If I divide them, what's my new function? No. So what's my new function? 7/3. Okay? 7/3. Okay? With me? Now, if life were only that easy, Nick. Right? Mm-hmm.
Right.
Okay? So there's my two functions. I want you to add them. I want you to subtract them. I want you to multiply them. And I want you to divide them.
What?
Yeah, it is.
Letters.
Yeah, it is. Yeah, I know. So f of x plus g of x would be
Letters.
3 times the 4th root of 2x plus 8 times the 4th root of 2x. They're right here, Nick.
Oh.
Abracadabra, there they are.
So that's how this unit's gonna go.
Alright, we're back. Yeah, it's something alright. I don't know if it's yeet worthy, but can I add those two together? Why?
Because of like terms.
What do you mean there's like terms?
There's like, combine like terms.
Right? Combine like terms, yeah, I get that.
The fourth square root.
Both have the same index, right?
Yeah.
Remember that number out in front of the radical, or the quote-unquote power of the radical
Yeah.
is called the index, so they both have the same index,
And they also have the same like square root.
and they have the same insides, right?
Yeah.
Yeah, so I can add them, right?
Yeah. It's
So 3 plus 8 is?
that's
11. I would have stopped you. So f of x plus g of x is equal to 11 times the 4th root of 2x. Now, my question to you is this. What if they weren't like terms? Then it just would have been whatever it is, right? Okay? Then it just would have been whatever it is. Okay? So there's adding them. Okay? Subtracting them. Can I subtract them? Because they're like terms again. What do I get?
I was literally
Right? Multiplying them. Right? So this is going to be like what?
24.
24 times the fourth root of 2x squared, right? Because there's two of them, right?
Yeah.
Can that be simplified now?
Right? Yeah.
You tell me.
I think so.
I think so too.
Okay, cool.
Okay. Because what exponent is associated with the fourth root? 1/4. So this is really 24 times 2x to the 1/4 power, then squared.
So that's going to be 24 square root of.
So then this is just going to be like 24x then?
Nope.
Is it 1/2 of 3?
What's an exponent of 1/2 though?
Oh.
Exponent of 1/2 means square root.
So why didn't we just get rid of the square roots or the fours altogether?
Because we didn't have 4 of them. You know what I mean? If it were square roots, yeah, I could have gotten rid of them because there would have been 2 of them. And my index on a square root is 2. Right? If for a cube root, I got to have 3 of them to get rid of the
Okay.
radical.
So you're saying like
For a fourth root, I got to have 4 of them. I only had 2 of them.
so okay.
You know what I mean?
But then okay, so if there's 4 of them, then wouldn't it just be 24 and 2x?
Times 2x, which
Okay.
would have been 48x. But there's only 2 of them. Okay?
But then can we like on homework and tests can we just see that and then just get rid of the 4 and keep the square root?
No. You gotta write it out. You gotta show all your work. I know. Mean old teacher. Okay, what about dividing them? Gotta pick a color. Oh, purple. Already picked it. What do we get? 3/8. Handle? Not too difficult. I mean, there's some thinking involved. Okay. Ready to try another one? Feels as if I double tapped. Oh, nope, must not have. Thought I did. You try them and you will see. So this is x over 4 plus 5 over x, which I would accept, okay, because you really can't combine those. But I would also accept here, so that my common denominator would be 4x, so that would be x squared plus 20. Right? Yeah. Same thing here. So this would have been x over 4, but now minus 5 over x. And so that would be x squared minus 20 over 4x. Okay. This one x over 4 times 5 over x. That one simplifies down to 5/4. X over 4 divided by 5 over x is x over 4 times x over 5, which then is x squared over 20. Yes?
Do you have to put the denominator then for that one?
After the divide sign or the bottom fraction. Yep. Have to. Good? Try that one. I get, for adding the two functions, I get 5x minus 1. Subtracting the two functions, I get negative x plus 3. Multiplying the two functions, I get 6x squared minus x minus 2. Dividing the two functions, I get 2x plus 1 divided by 3x minus 2. Yes?
How is that one not, like, how do you not combine them?
How would you combine them?
Well, what I put, obviously it's wrong, but I put 2/3 x minus 1/2.
If you're going to cancel something out in a fraction, it has to come out of all of the terms on that particular one. Okay? So if I wanted to factor out an x on the top, both of the terms have to have an x in it.
Okay.
Okay? You probably heard some people in the math department refer to that as the whack-off method. You can't just whack off the x's. Okay? Right? It's got to be factored out first, and then it can be reduced. Because really, then you should have gone even further and done 2/3 minus 1/2 and gotten 1/6.
Well, I had 2/3 x.
Oh. So you just drop one of them then. You know what I mean?
Oh, yeah. Because
Yeah.
I divided the two.
Yeah, I don't know what you did. It wasn't real math.
Okay.
Okay.
I did that last year too. Sugar said I did voodoo math.
Yes. So if two teachers now told you that whatever you're doing is not real math, maybe you want to start listening. But who am I to judge? Okay. Domain of a function. Second one. Number values that can be inputted in the function in order to evaluate it. Okay? So the domain is all those numbers that we can put into the function, and we get something else. Okay? Inputs. Okay? the domain is the set of all possible input values. Usually it's x. Could be t if it's a function of t. Could be theta if it's a function of theta. Okay? Whatever. Okay? Now, thinking about math and what you know about math, what are the two things that we have to watch out for in math that wouldn't give us an output? What are the two things that we have to watch for?
Double X value.
Hmm?
Like the double X value.
Like, what do you mean double X values?
Or like the repeats, like where each target has. No.
That's not going to affect us putting a number in.
Okay. It's imaginary number.
So what produces an imaginary number?
A negative square root.
Negative square root. So that's something we got to watch out for, right? Okay. So the first thing that we have to watch out for is something called an even indexed, because that number is an index, remember, radical. So what I mean by an even indexed radical, square root, fourth root, sixth root, eighth root, okay? All of those are even indexed radicals. And what has to be true about an even indexed radical?
The x-axis.
This inside part right here has to be what? It's got to be positive. Because if that inside is negative, then we're go to imaginary land. Okay? That's one thing we've got to look out for. What else do we have to look out for? Yes, ma'am.
Negative exponents.
But we make those positive just by moving them down to the bottom. You know what I mean? That's not going to stop us from getting out an answer. You know what I mean? Because 2 to the negative 2 power is just 1/4.
They have variables.
I'm okay with variables because you just plug numbers in the variable spot. All good answers. You guys know it. I know you do. Don't like imaginary numbers, so we gotta watch out for those. What's the other thing that would make a function not work? Nope. You just make them positive and move them. What about fractions? When's a fraction not a fraction? Decimals are fractions.
When it's undefined, when it's numerator is 0.
When the numerator is 0?
Denominator.
Which one?
Both.
Yes. Yes.
'Cause
No.
in either case, it makes a line.
No.
Okay, when the denominator is 0.
So the second thing we got to watch out for is fractions. Because our denominator downstairs, the bottom parts of our fraction, has to be something other than 0. Because we can't divide by 0. Okay? So, here are some examples of functions. A, B, and C. Function A, function B, and function C. Okay? So, we're looking for two things when it comes to domains. We're looking for radicals that are even indexed, and we're looking for fractions. Okay? In the first one, in function A, in A of x, do we have a radical? No. Do we have a fraction? No. So are there going to be any restrictions in our domain? No. So what's our domain then? All real numbers. Function B, B of x. Do we have a radical? No. Do we have a fraction? Yes. Okay. What's the rule about fractions? The denominator can't be 0. So x minus 2 cannot equal 0. So what? So x can't be 2. So the domain of this function is all real numbers, but x cannot be 2. It can be any other number that you think of, Mace. But if that number is 2, not going to happen. Okay? Third one. Do I have a radical?
Yes.
Is it an even indexed radical? Yes, it is. Okay? So what's the rule with radicals? The inside has to be greater than or equal to 0. Because I can still take the square root of 0, right? Square root of 0 is 0. Okay, so that's why the equals part's there. So this is basically saying here that x then has to be greater than or equal to 0. Right? So the domain on this one then is all real numbers with the exception that x has to be greater than or equal to 0. Okay? Now, let's go back to that second slide, that first example that you did by yourself. Okay? So we had m of x and n of x, right? Okay? Then I said, now we've got m plus n of x. And we said that that was x over 4 plus 5 over x, or we wrote it as x squared plus 20 over 4x. Right? Okay. Now, what I did is I took two functions. I took m and n, and I combined them using some kind of operation. So to find the new domain now, I've got to look at the domain of m, the domain of n, and the domain of my operation. Okay, we'll look at 3 different ones. Okay? So, the domain here of M is there a radical in M? Nope. Is there a fraction? Yes. What's my rule with fractions? Denominator can't be 0. Can 4 ever be 0? No. So there is no restrictions on this one. So far, I have no restrictions in my domain. Still all real numbers. Right? Okay. Now, I've got to look at the domain of n of x. Is there a radical? No. Is there a fraction? Can the denominator ever be 0? What? If x is 0, right? So that one's all real numbers, except x cannot be 0. Now I look at this one. Do I have a radical? No. Do I have a fraction? Yes. Is it a possibility that that denominator could be 0? Okay. When? When x equals 0. So that again would be a restriction. Right? Okay. So, first input, I'm okay with. There's no restrictions. Second input, I can't have 0. Okay? Third input, still can't have 0. So the domain of my composition is all real numbers, but x cannot be 0. It's a lot of logic. It's what's going into it that makes it not work. I think there's supposed to be a dot down here. Okay. When we did this before, when we did m times n, we got 5/4, I believe, right? Right? Okay? All right. So the domain of m is still all real numbers. That hasn't changed because my function hasn't changed. Right? I didn't magically change my function in between these two examples. The domain of n still hasn't changed. Right? Okay. But now, what's the domain here of my new function? So what's the domain of this one? Can 4 ever be 0? No, so that one's all reals, right? So my domain here is going to be all real numbers, but x can't equal 0 because I've got that input. If I start out with x equals 0, I can't get to the product because n doesn't work out. Understand that? There's a little bit of a dot right there. I think it's supposed to be there. Yep, multiply. Just a bad dot. I don't know where my dots all went. I have to go back and fix that. Okay, do that one. All real numbers for that one. Neither of the functions k, d, or k times d had any fractions or any radicals. So it's all real numbers all the way through, no restrictions. Agree? Okay. So that's k of x divided by d of x. Why is it doing that? The domain of k is still all real numbers. The domain of d is still all real numbers, but the domain now of k of x divided by d of x, now I've got a fraction that I've got to deal with, right? So 4x minus 7 cannot equal 0. So 4x cannot equal 7. So x cannot equal 7/4. Agree with that? So that tells me then that the domain here is all real numbers, but x cannot equal 7/4. Okay? So no matter what, I put it in on the top, it doesn't matter. If I put 7/4 in on the bottom, it's not going to work out. Okay? I can put 7/4 into k and it'll work. I can put 7/4 into d and it will work. Okay? But if I put it into k of x divided by d of x, now it doesn't work because now I'm dividing by 0. Okay? Have a great day. Thanks for playing along.